Right, good afternoon. I'm Duncan Baker-Brown. I'm an practicing architect, but I teach at University of Brighton School of Architecture, and I have done quite a lot of research and practice over the last 25 years around sustainability and closed-loop systems, and done quite a lot of practice as well. What we're going to focus now is a big elephant in the room, really, around low-carbon solutions, which is how do we deal with concrete, which is ubiquitous. We can't live like we do without it. So we've got some of the thought leaders and experts from this country who are going to offer up some ideas and some solutions. We've got 5 speakers, and I'm on the wrong page. And we're going to start with Tim Foreman from the University of Cambridge. Tim is a research and academic at the University of Cambridge, and he's Deputy Course Director of the MSc in Interdisciplinary Design for the Built Environment, and a Research Associate and Teaching Fellow in the Department of Engineering. He's particularly interested in the challenges associated with built assets under future conditions. Sounds like just the person for the job. Tim.
Thank you, Duncan. Thanks all very much for being here. So I will jump right in. I wanted to give a very quick overview of where we are in terms of the global challenge of carbon, the challenge of adapting concrete and our use of concrete to that future, and then run quickly through some of the potential opportunities, but also some of the barriers to driving change in our use of concrete. So we all know that concrete is a wonderful material. We might even call it a wonder material. It's used really everywhere around us. We have come to take it for granted as part and parcel of how we build and construct our built environments. And in fact, when we look around the UK, the vast majority of cement is being used in buildings, not in roads or in infrastructure, but in buildings. And we know that across the UK, the primary use of concrete across all sectors is in fact in concrete frames for buildings, which we might argue is perhaps not an absolute necessity to be using concrete in that sort of application, but nevertheless a highly useful and affordable material it is. In fact, cement is such a wonderful material that in fact it is, next to water, our most consumed resource globally. And when we think about the carbon intensity of cement, we use so much of it that in fact if it were a country, it would be our 3rd largest emitter. That's the 3rd largest emitter globally, strictly from the production of cement itself. How do we build our built environments without cement? I think arguably we know that we cannot, so we need to find new ways of adapting. In fact, it's so ubiquitous that even we need it to be constructing our renewable generation technologies, such as windmills or photovoltaics. So what's the problem with cement? Well, I might boil it down to 4 principal categories: energy or carbon, water, sand, and the waste that it typically engenders when we build with it. So in terms of energy and carbon, we know that roughly 8%, 7 to 8% of global carbon emissions are coming from the production of cement. In terms of concrete, of which cement is of course a part, globally about 9% of industrial water usage, or almost 2% of all global water usage, is being tied up in the production of concrete. Using sand as an aggregate is not a necessity, but of course is by far and away the formulation that we look to, and we are using it at such a rapid rate that indications are over the next 30 years or so we will be outstripped of our supply globally. We will have no more available resources of sand that could be economically tapped. And then lastly, thinking about waste, concrete, in production of concrete or production of cement is not necessarily creating much waste, but the use of concrete in our built environment is a very large factor of our waste. So much so that when we think about the waste that is leaving construction sites at the end, building sites at the end of their lives, somewhere between about 40 and 85% of all of that waste tends to be concrete in the UK. And when we think about residential buildings built of concrete in the UK, some studies have found as much as 840 kilograms per square meter of living space is being produced just as concrete waste at the end of an asset's lifetime. So I'll run very quickly, as I'm being sort of tasked with giving you a bit of an overview and introduction to the issue, I'll run very quickly through some of the sort of inherent problems that cement manufacture carries with it. In essence, much of it boils down to this. Our current way of producing cement, which accounts for about 98% of the cement that we're producing globally, is Portland cement. Portland cement, by its very definition, creates CO2. You don't need to remember your chemistry class too much, but it helps to recognize that this is intrinsic, this is a problem. Strictly the conversion of limestone and clay through the application of heat to produce clinker, the core component of cement, is itself responsible for about 50 or 60% of the CO2 emissions of concrete itself, of CO2 itself. So that is a chemical reaction. We, as it stands, using the raw ingredients that we are using, we cannot get away from that. And the balance of those emissions, which aren't what we'd call process emissions, the balance of those are coming from the heat that's required in this process and the energy that's being brought in to the production facilities. So we know that this is in fact creating a growing problem in the US. This is not, in the world, this is not a problem which is going away. This is a graph showing you from about 1930 to present the process emissions. So we talked about that chemical reaction that occurs when we produce cement. That's what this is showing you. It's not accounting for the direct heating or the indirect electricity supply, but strictly the process emissions are growing and growing and growing. When we look at cement production globally, it's a similar story. Much of this, the vast majority of this, is actually happening in China, but countries like the UK, across Europe, we are all continuing to produce cement at considerable quantities. So we know that currently we're producing globally something in the region of 4 billion metric tons of cement, and under a business as usual trajectory, that is predicted to increase to 5 billion by 2050. So when we talk about having a zero carbon future, we talk about zero carbon by 2050, this is inherently a conflict. And I'll run very quickly through the carbon challenge. I think we're all aware that this has become a defining issue of our times. The International Panel on Climate Change, a union of scientists around the world, have produced in the last year and a half a projection of where we need to be, what we need to achieve to reach zero carbon by 2050, and we know that that's what's required to keep our chances of exceeding 1.5 degrees Celsius to 50%. So if we want to keep our chances of having a global temperature increase to 1.5 degrees C, if we want a 50% chance of doing that, we need to achieve what's shown there on the graph. We need to be achieving zero carbon by sometime between 2040 and 2055 globally. That's a stark challenge. I like to show my students this. I think this helps to demonstrate it, helps to get your mind around what that feels like. As built environment professionals, what do we need to be doing? It's rapid decarbonization. So to be doing that globally, we need to be reducing our emissions by about 7.5% each year over the next decade. And to keep in line with the Paris Agreement, which is not 1.5 degrees, but is 2, or some estimates say 3.1 degrees C. Just to meet that objective alone, the cement sector needs to be reducing its emissions by approximately 16% year on year over the next decade. So that's a very stark challenge. I'd like to run through quickly some of the strategies of how we might get there. I would say, first of all, let's not build. I think that's perhaps a controversial statement here at Future Build, but that is the obvious truth. If we want to decarbonize rapidly, we need to be simply not building as much, or we need to be building with less, or we need to be building with lower carbon materials. So I would say, as a hierarchy, it's build less, use less materials to do that, or build differently. We need to be thinking about embodied carbon. That's a term that we should all be very familiar with by now. We need to be understanding that it's not just the operational energy, it's not just the energy that it takes to build or operate a building that matters. It's all of the carbon from the point of origin through to the end of the asset's life that count. And when we think about design or construction, we need to be thinking in terms of embodied carbon. Is cement the right material to use, or is concrete the right material to use? Sometimes it is. It has many great advantages, but often it's alternatives that make more sense, alternatives such as timber or steel. So within the supply chain, there are opportunities. We are seeing the introduction of more and more supplementary cementitious materials. Things like GGBS or fly ash are becoming more and more common. In fact, in the UK, they're accounting for about 20% of our carbon reductions that we are achieving. Fuel switching, the fuel that's used to heat that clinker, and then finally carbon capture and storage, though notably we don't yet have proof that those technologies are working. We need to be doing more with less. We need to be optimizing our structures. We need to be creating lightweight structures. We need to be looking to technologies with which we can achieve the same structural properties without as much material. We need to be constructing differently, I would say. Can we use precast concrete to our advantage? Sometimes we can, sometimes we can't. It may cost more, but typically it gives us lower carbon. It's important to specify only what we need and not over-specify. I think we are all familiar in the industry of how easy a habit that is to slip into. In thinking about how we use cement in the actual process of construction, I think we can become leaner, we can become more efficient, and that's very important to do. We need to be reducing the impacts that are required to transport materials to sites and then from sites at the end of their lives. And finally, closing the loop. We are all hearing more and more about the circular economy. How can we use cement as part of that? I would argue that designing for deconstruction, creating buildings that can be disassembled, having a national database for these waste materials, or I should say materials at the end of their lifetime, is critically important. And finally, there is a lot of talk about the potential for accelerated carbonation, so that is the absorption of CO2 from exposed concrete, or more promisingly from exposed concretes like magnesium concrete. That is a real opportunity, but I think we are probably making too much of that opportunity than is actually a reality. There are lots of issues with why that's not actually as achievable as we might like to think. Skipping quickly along, there are emerging trends, I would say, that are very promising. Our ability to use computational power to predict, to structurally optimize our designs is growing year on year. It's important that we harness that. Can we harness the opportunities that additive manufacturing, 3D printing offer us to dematerialize, to use less, to apply cement, or to supply concrete only where we need it? I would argue we can. And further opportunities such as AI all should be driving forward these capabilities. So very quickly, I'll run through just a couple of the barriers and let you read the rest. We talk a lot about the use of GGBS, which is a byproduct of steel manufacture, and of fly ash, of coal power. Those are very good resources. However, we have finite stocks of them, and in a zero carbon future, certainly in the UK and in Europe, we really do not have the stocks that we need to decarbonize cement manufacture. Other places may have a different story, such as China or India. I think part of the problem really is that the global cement manufacturing industry is a very concentrated, consolidated industry. There are a small number of major producers. Those producers hold the vast majority of intellectual property that we need for decarbonization. They have been slow to bring new products to market. They've been slow to decarbonize their own industry. So we're reliant in part on them and on SMEs who are holding some of the other innovation patents to drive this change forward. So we need to be moving past this reticence to change our business models. We need to be introducing the real cost of carbon in our decision making. We are, unfortunately, I think we are still reliant on the R&D from SMEs and from major producers to do this. So in summary, how do we achieve this dematerialization? How do we achieve the decarbonization of our cement supply? How do we transition to using alternative materials, novel cements, new cement mixtures, and how do we ramp up the sequestration potential of concrete? I would argue that it's really down to 4 simple but yet very challenging directions. The first is we need to continue the drive toward more innovation. We need to fund more innovation. We need, of course, more research. I would say that as I'm a researcher. We need to demonstrate these products and their ability in the market. And lastly, we really need to drive the market through all of our practices. We need to be driving the market for cleaner and lower carbon cement and concrete. Thank you very much for your time.
Well, hello? Yeah.
Thank you, Tim. That was saying it as it is, really clear and direct. Our second speaker is Elaine Toogood, who's the senior architect and head of architecture at the Concrete Centre. She's a qualified architect providing architectural advice, project and technical guidance related to the use of concrete, with a particular expertise in sustainable and visual concrete. She authors technical guidance which has included concrete and BREEAM and material efficiency publications, and is a regular contributor to Concrete Quarterly, of which she is a joint editor. She sits on working groups from the DEFRA Property Level Flood Resilience Action Plan and the London Climate Change Partnership, as well as the RIBA's Sustainable Futures Expert Advisory Group. She's also current chair of RIBA South East, and I don't know how you got enough time.
Not know why, I don't sleep, and I certainly don't clean. That's why I don't. Yeah.
Okay, an unclean Elaine's going to talk to you.
Thank you very much. Yeah, I clean myself. Before anybody's worried about that, don't ever clean my house. Anyway, dust isn't that bad. So I have got anyway. So thank you very much. Tim, we've got too many overlaps in our slides. Who'd have thought that? So I'm Elaine Toogood, as you said, Head of Architecture at the Concrete Centre, and our stand is directly behind you. And if you don't pick up lots of the stuff today in terms of what we're saying, go over there. We've got loads of guidance, loads of innovative concrete, things about the future. So I'm coming at this as an architect from a bit more of an architect's perspective. It does actually say, what is it? How is the question that was asked, how is concrete going to be viable in a low-carbon future? So I would argue, actually, in some respects, it already is. Maybe controversial, but there are many ways. As Tim's already said, it's blooming useful stuff, right? There's a lot of it used, and actually, if we are, using, it's pretty essential for infrastructure, green infrastructure, everything that we do, fundamental to the way that we live today. So, what's going to change about the way that we live today that's going to mean that we don't need its performance? Okay, that's a really important question that we've got to ask ourselves. But it's a question that we are all asking ourselves, right? It's a critical time. Everything is under scrutiny. It's the performance of concrete, not just the fact that it's really good at fire and it is everywhere and actually is really cost effective, but it provides us with lots of really good key benefits that support the way that we live today. If we're going to change the way that we do things, maybe we can do it with other materials. What's going to give? I would argue, actually, a lot of these are all sustainability benefits. I'd argue in the future, in a climate change emergency, concrete might even be more needed. It provides passive cooling. That risk of overheating, a really fundamental risk that we all know is affecting our health within the UK. And I'm talking really UK when I'm talking about this. Floods, we know we've been suffering from all of those things today. It's really, really important if we're talking about climate change adaptation, climate change mitigation and issues to do with climate change, we have to look at both sides of the coin. You cannot talk about one without the other. It's now embedded within the way that we're looking at these things. We've got to think about mitigation and adaptation. There's no point in doing one and not the other. You'll actually just be undoing all that good work that you're thinking about doing in the first place. So what does a construction in a low-carbon future need to do? It needs to be energy efficient. Concrete, like every material, can do it. Loads of passive house examples, more passive house examples than any other type of material globally, believe it or not. It can get there. That's all about our detailing as architects, isn't it? It's energy efficiency, it's about fabric performance, it's attention to detail. We just got to do that better than we've been doing, maybe. The thing that concrete brings to the table is got added value. It's got thermal mass. So it means your structure can also passively cool, which means it can also means that reducing less energy use throughout our building. The definitions for net zero at the moment are all about operational energy. They're not yet about embodied. I'm going to get onto that in a minute, okay? But it's a really important factor. We must not forget that. So what is the credentials of concrete? We've talked about it before. I would suggest that probably UK concrete is much better than you'll think it is already. This is the industry have been decarbonising for decades. This isn't new, okay? It's 30% lower than it was in 1990. They know it. Now there's a picture of the UK there because concrete is already local. If you're building in the UK, you're going to be using concrete that's pretty much made in the UK, sourced in the UK. That means it's locally responsibly sourced and it hasn't got all those transport issues that we're talking about. But how have the industry been doing it? They've been decarbonising, they've been fuel switching, all of the things that Tim talked about. It's not the end of the road. There's still an enormous amount that could be done, but they've been doing it. There's been a commitment to do this. greater use of other alternative raw materials you talked about, more efficient manufacture. So is it enough? It's a good question. A lot of people will say it's not fast enough, and there's a point to be that. But a zero carbon future, people will say to me, so is there such a thing as a zero carbon, will there be a zero carbon concrete? Will there be a zero carbon cement? Well, I believe there will be. If you ask me, with all the different things that are there, I absolutely think there. In 2013, why do I think that? Because in 2013, there was already a commitment to an 80% reduction. That was committed to meet the Paris Agreement. So it's going to take something to get that extra 20%, but they're working on it. I've got a lot of concretes working, a lot of colleagues working really hard on that, looking at it. It's going to take some transformative industry to do that. Carbon capture at use. These are some of the things that are already going on. Alternative cements, new cements. Use of different types of binders that actually don't rely on Portland cement. Those are all coming through. But the point is, we don't have to wait until that's going to happen. If we don't believe it's going to happen, it depends we don't have to wait. We can do huge amounts now. And as architects and engineers, we should all be doing those things now. And that's what we do at the Concrete Centre, is provide lots of guidance about how to do it. You can make significant changes to the carbon footprint of concrete now if you specify it right, if you design it right, more efficiently, all those things there. Use of different types of cementitious materials, ternary cements, as the new standards are going to change. Current standards are going to evolve and change in the next year or two to offer more opportunities for lower carbon concrete. Today, without needing to go to a new standard or wait for a new one, you can use a concrete with 80% cementitious materials, so only 20% ordinary Portland cement in it. That's today, that's not waiting for anybody. So why aren't we, you, doing it? Okay? Don't wait around, ask the questions. Now, of course, there are some barriers and some things to think about, but concrete isn't always as high carbon. Lou Letty report, I hope you've all seen it, brilliant document that's come out. Actually, I was quite surprised to read this, but it was an example that came from Hawkins Brown with their brilliant life cycle analysis assessment tool. Look, concrete was one of the lowest and the low carbon solution for cladding. Why? Because it's simpler. It's far less other stuff that's got to go in there. What's clear is that we've all got to understand embodied CO2 much more than we do. And the thing about concrete is it does lots of jobs. Lots of other materials need lots of other things to help you do the job, and maybe that doesn't all get counted at the same time. So what's clear? Absolutely, we've got to use less stuff. We've got to use less of everything, haven't we? So use concrete, but use it in an efficient way. Structural design, maybe we've got to go back to rib slabs and look at thin shell technology. Or is this a future of what it is? 3D printing and looking at different ways of getting all those benefits with concrete, but far less of it. Using concrete to use less other stuff. We don't need to line it. It does the fire performance without it. Acoustics as well, so less other materials. Use less stuff. Actually we're already doing, you talk about recycling the circular economy, a future environment that is zero carbon will be a circular economy. So buildings, structures designed to last for a long time, reuse them. Not only of obviously recycled aggregates, we've talked about this, and actually one of the benefits about recycled aggregate in the UK is we're already absolutely at the max. All that stuff that's been produced from site, all of it, 92% in the UK, is being used as recycled aggregate. There's nothing going into landfill. We're already using that stuff, and it's carbonating, it's sequestering concrete. So that's the summary really. We can use concrete, recognise that we can do it better, design for it to last for a really long time, use it where it's appropriate, design for reuse, design for be reused, demounted. It's got a long life, it's got a lot of benefits. And actually, I think, it really does have a role to play within a zero carbon future, so long as we just got to focus a little bit more.
Thank you, Elaine. Brilliant. Good points at the end. Okay, we've now got Dr. Joe Guy from the Environment Agency. He's Environment Manager at Team 2100, the Environment Agency's 10-year asset management program delivered by an integrated delivery team of client, consultant, and contractor. Within this framework of Team... Oh, you got your thing. Good. That's quick. I'll finish. Of Team 2100, we'll refurbish and replace tidal flood risk management assets in London and the Thames Estuary. And that's going to use a lot of concrete.
Over to you, Joe.
Okay, thank you. Right, so as Duncan told us, it's good to get his name straight of all. So I work on the agency's largest flood risk management program in the UK, which is looking at maintaining flood risk assets from Teddington in West London, the very far end of the squiggly Thames, right the way out to Southend and Shoeburyness. So it's a fairly large site. So I've come to talk to you about low carbon and what we're doing about it, because we're kind of at the sharp end, we're trying to deliver stuff. So, a bit no closer? Right, good. Okay, so the question is, well then, why do it? Well, we spend most of our time, if I read the FT too much, it's my fault, but the FT is all over this. All of this comes from the front page of the FT over the past 6 months. Business is getting this as an issue, and it's quite clear that we need to step up to the sustainability agenda as a whole. So, the agency has been quite clear about its ambitions around carbon. In October last year, it set out quite clearly that it has an ambition to be net zero by 2030. So that places us 20 years ahead of where the UK says it wants to be, or the UK government says it wants to be, and we're looking to explore options to be absolute zero by 2050. So that means we're setting ourselves some really quite significant targets. And what does that look like in reality? Well, the agency currently considers its emissions are around 180,000 tonnes per year, and which splits out in quite simple terms to 44,000 tonnes which we do by doing our role around flood risk management and around regulating environment and business, and 136,000 tonnes through our supply chain. Well, our supply chain, when we look at it, we discover that actually 80,000 tonnes of that 180,000 tonnes a year, so we take it out, we look at it, is around constructing flood risk management assets. So that's a large amount of carbon we're trying to deal with. So the agency has a wider sustainability ambition, and I think we just need to talk about that so that you can understand where we're coming from. It's looked at 4 areas, so it's talking about responding to the climate emergency, that's our approach to looking at net zero carbon. Delivering environmental net gain, everybody started to hear about environmental net gain and biodiversity net gain. You're all going to nod at this point in time? Generally? No? Yes? Some of you are? Good. Benefiting people and communities, that's what we might term as social value, so making sure that whatever we do doesn't just deliver a flood risk management asset, it delivers a benefit to the communities that we work in and amongst. And then finally, optimising our use of resources, so that's where we start talking about the circular economy and how we're going to look at the circular economy to guide our material choices as we move forward. So probably now you're thinking, man, I came here to talk about concrete, and this guy's talking about optimising our use of resources. Well, this is kind of like for me and for Team 2100, for the wider agency, this is where it gets down to. We have to make physical choices around what we are and aren't going to build, and how do we approach that. So when we talk about optimising our use of resources, and I was rather hoping I could run away with a microphone and point at this, but we've said that we want to do some quite important things. We want to purchase products and materials that are most socially and environmentally responsible for their life cycle. Do we want to reduce our consumption of resources? And we want to eliminate waste from products and materials. So that's some quite big, broad brush ambitions that we have to try and deliver those. So, well, what's happening then? So that's great. These are all nice world good things to talk about. Well, we're looking at 3 areas within the aegis of Team 2100 and the integrated Team 200 in integrated delivery team, delivery of flood risk management assets. We're looking at the use of integrated green-grey infrastructure, which is where we attempt to understand how we can add additional value to concrete structures where we use them. We're looking at options for low carbon and cement-free concrete, and then we're looking at civils redesign and the use of sustainable materials. So let's talk about that. What does integrated green-grey infrastructure sound like, or IGGI? It all sounds a bit kind of funky, doesn't it? So essentially what that's trying to do is trying to find ways in which we can add a biodiversity or a social value to the use of significant hard infrastructure. Now, in simple terms, that means we have a continuum from kind of grey infrastructure over on the left-hand side, the typical stuff we might be talking about, a flood wall that might be the height of this wall behind me here, right the way through to green and green-blue solutions. So that's natural flood management. And you'll have heard much of that about that in the press over the past few days. And there on the right is an example of natural flood management, where we're trying to use different ways to hold water up in the upper catchments. But in the middle, there's a whole opportunity for us to think about how we do more. So there we can see on the far left, we can kind of retrofit things onto concrete walls to add a level of biodiversity that wasn't previously there. We can attempt to build things differently so they actually retain water and provide some benefit, or we can move through the middle, put some sort of texturing on, and then we kind of move into greener and greener solutions. So what we're interested in is where we're working in central London. Ideally, I'd love to have a piece of green infrastructure, a bit of natural flood management, but nobody's going to give me a lot of money to buy a large amount of real estate in London so I can set back the flood defence. There'd be a lot of annoyed people, understandably. So we've got to find ways of dealing with the grey infrastructure and how we improve that. So then let's talk about some options for low carbon and cement-free concrete. So here we've got an example of a solution in East Anglia where we had a traditional wall, which was on the far left-hand picture there, but we knew that we had to increase its resilience in order to deal with the likely pressures that were going to be put on it by tidal surges in flood events. So we had to think, what can we do to reduce that carbon load on that options, on that asset, if you like. So what we managed to do was use a chem-free concrete in order to deliver a reduction in CO2. And so that was, if you like, as you can read, a 67% reduction, even above what we would get by using a 50% GBBS concrete. So there's quite a significant benefit there for us to think about, and how we attempt to use those and move those onto more of our works. And so part of the reason for me standing here is really to say to the industry and to say all of you here, we are looking for these kinds of solutions to come from our supply chain so that we can help deliver a more resilient future. So we talked about civils redesign. So this is where we're kind of trying to do something a little bit different. So traditionally we do have to build some big structures for wave walls, for large flood defence assets. This is an example of something on the south coast of Britain, a structure which is about 5.5 metres tall. Normally it would be a big flat concrete face. We can't really do much with that. Well, it looks like a big concrete face, doesn't it? There's devoid of any form of biological life. So we're looking at different techniques that we can use to add additional texture to that concrete at quite a depth, probably around 60 to 80 millimetres, in order to give that concrete an ability to trap and hold some form of biotic activity, so we generate niches. Now, interestingly, not only does doing this generate that biological outcome, but it also makes the concrete more resilient to the drying and wetting process and the heat, the thermal characteristics of it. So it means that we end up with a longer asset life for that same asset. So actually we're kind of winning in two ways here, if you like. So that was a final thing. And then finally, I just wanted to talk about sustainable materials. Now, it's all okay us talking about saying, well, we want to do something with concrete, but you all quite correctly say to me, but Joe, you build other stuff. So whilst we can look to attempt to change the admixtures that we use with concrete, or different types of concrete, we also need to think about the other assets that we own and operate. And so here we can see that we've started to look at a technique using cradle to cradle as a process, where we can start to swap out some of the materials that we use. Those materials where they are cradle to cradle certified give us a surety across all of our sustainability, our 4 sustainability ambitions, that those materials meet those sustainability ambitions. So here we're really looking for the market to start to consider the fact that we will be looking for, to be aware that we will be looking for cradle-to-cradle certified materials, and that means that they will need to start to look to see if they can supply those to us, because if they don't, we won't be buying them, as simple as that. Okay. So I think that is all I have to say. Sorry, I cantered through that at a pace.
Thank you, Joe. Good work. Okay, our third speaker is Dr. Andrea Lampropoulos. Up you go, from University of Brighton, where I work. He's principal lecturer in civil engineering at the university. He obtained a diploma in 2003. His main research agenda spans the areas of novel, sustainable, and high-performance construction materials and strengthening retrofitting of existing structures. So, over to you.
Thank you very much, Duncan. My talk today is actually focused on cement-free concrete. So many of the previous speakers talked about this new type of concrete, which is mainly concrete without cement. So today I will go a bit more in detail on how we can make this type of concrete and what are the main benefits that we can get. A little bit of introduction. So this is me. I graduated, I got a civil engineering diploma, then I moved to master, PhD degrees in structural engineering, so I'm a structural engineer, but then I moved to the area of novel construction materials. So we have our research group at the University of Brighton, where we are mainly focusing on sustainable and resilience engineering, so we're dealing with aspects such as materials, structures, and so on. My main expertise now is focused on the development of novel materials, including the cement-free concrete, for structural applications. So we actually want to use cement-free concrete, but also to have very good properties, good strength and good durability. Regarding the global issues, I'm sure you know most of these things, so previous speakers told about this. We have the energy and climate change. At the same time, the population is continuously increasing, and clearly we have the need for sustainable development. This is a very nice definition given by Brundtland in 1987. So actually, according to this definition, sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So we know we have CO2 emissions. We have quite a big jump ever recorded worldwide. And clearly this is linked to global issues. We have the increment of the average surface temperature. Therefore, this leads to the average sea level increment and reduction of snow cover. Therefore, there is an urgent need at the moment to work towards the sustainable development. How we can do that? Clearly, we need to minimize consumption of non-renewable energy, minimizing negative environmental impacts, but at the same time, we need to maintain human satisfaction. So clearly, we can stop building, but this cannot be the solution because we need at the same time to keep our structures, to continue building structures, so we need to invest on using new materials, but also we need to keep working on how to reuse our existing structures. So the 3 R's, reuse, reduce, and recycle. What I'm actually working on is to use waste and recycled materials to make concrete, but also to use this type of concrete to repair and strengthen the existing structures, the existing damaged structures, so as to be able to reuse our existing structures as well, rather than demolishing and building new ones. So actually, what I'm doing is I'm trying to invest on new materials, cement-free materials, which give good properties and can be used for the strengthening of the existing structures. We know that concrete is the most widespread construction material worldwide. The numbers I have is the annual worldwide consumption between 21 and 31 billion tons. And we are aware that the main environmental impacts are due to the concrete production and also due to the transportation. We know that the cement, which is the main part of concrete, is responsible for at least 5%. Probably the numbers are slightly higher, like 7 or 8% of world CO2 emissions. At the moment, we are using as cement substitutes fly ash, GGPS. Some of the previous speakers talked about this. And we use other materials as well, limestone, metakaolin, silica fume, and so on. So fly ash, probably you know what it is. It's a byproduct from the combustion of coal. So this is what we collect from the chimneys of the coal-fired power plants. It's a waste product, and current practice, something like 15-20% replacement of cement, or can go in very high fly ash concretes up to 40%. We have some benefits such as increased workability, higher strength, less shrinkage, and we have some drawbacks too, so we can have some longer setting times, which can be detrimental for the early age strength of concrete. So we need to be careful when we are using these materials and at which percentage we can use them. Another material we're using quite a lot is what previous speakers talked about, GGPS, ground granulated blast furnace slag. So it's a byproduct of iron production. And this can replace up to quite high percentage, 70, 80%. And we can have some good benefits in terms of strength and workability, but again, we need to know how to use these materials. What I will present today in the next few slides is what we are doing on the development on cement-free concrete materials. So actually, we are replacing, it's a total replacement of cement. We use only waste products, only fly ash and GGPS. And our task is not only to use waste products only, but we also want to achieve high strength and good properties so that these materials can be used for structural applications and can also be used for the repair and strengthening of existing structures. So actually, this is an application which can have a quite important environmental impact because actually the UK cement production is something like 10 million tons annually, and we know that 1 ton of cement leads to something like 0.8 tons of CO2 emissions, so we can save something like 8 tons of CO2 emissions annually. How do we make geopolymer concrete? So we use waste materials, normally fly ash, GGPS, kaolin as well. We can use aggregates, but we also need to do the activation. So we need to add some chemicals. So we normally use sodium hydroxide and sodium silicate or potassium. So we need to do the activation in order to provide the strength. So actually, we have the waste materials, aggregates, the activators, and we can have the geopolymer concrete. I will present 2 or 3 papers of our recent findings on geopolymer concrete and on the use of this material for structural applications. So this one is focused on how to use concrete for in situ applications. So most of the materials we are using so far is materials that we use quite a lot of fly ash, and actually we need to have heat curing, and we can get a very good strength in one day. This is fantastic for precast applications. What we're focusing now is on material which gives quite good characteristics for in situ casting as well, and is a user-friendly, non-corrosive material. So we used combination of GGPS and fly ash. The chemicals, potassium mostly was used here, some super plasticizer and sand. And actually, the concept was to optimize the process, so to find what is the optimum mix design in order to have good early strength and also good ultimate strength without any heat curing. So actually, we had different percentages of fly ash to slag ratio, and we checked how this affects the strength, but also we checked how this affects the workability. So the workability is a quite crucial point when you work with these materials. So practically, the more you increase the GGPS, the less the workability, but the higher the strength. So we end up with our mixed composition, which is good for in situ applications, but also has good workability. Then we moved on the actual application of this material for the strengthening and repair of existing structures. So we used the mixed design that we developed in the previous study. We added appropriate type of fibers, steel fibers, polypropylene fibers, and we actually used these materials, which has now a very high performance, good energy absorption, good tensile characteristics for the strengthening of existing elements. So we had our reinforced concrete beams, and we cast additional layers using this geopolymer high-performance concrete. And actually the findings were very good, so it was quite promising the fact that the structural performance was significantly improved, but at the same time we did some accelerated corrosion tests, and we found that the geopolymer can also protect the steel bars from the corrosion. So this can also lead to increased durability, which is very important for structural applications. So coming to my final slide, some general remarks regarding geopolymer concrete. We can have very good mechanical properties, very good durability, and this can be good for in situ and clearly quite good for precast applications. We need to work a little bit more on the use of alternative resources, since the PFA and the GGPS have quite limited availability and will become even worse in the next 10 years. And we need to have a better understanding of the characteristics so as to allow extensive use of this material in industry, and clearly we need to have codes standards so as to allow the use of cement-free concrete in construction. Thank you very much for your attention.
Thank you. Thank you, Andrea. That was fascinating. Okay, last but not least, Richard Kershaw, Technical Manager, Materials UK Cemex. Richard has been employed in the technical and quality management field for over 30 years. He's been involved in the development of many innovative products, including high-performance self-compacting concrete and dry silo sprayed concrete. He's responsible for a team of specialist technical managers who focus on product conformance, technical guidance, and product innovation. This is what we need again. Thank you.
Okay, thank you, Duncan, and thanks to FutureBuild for the opportunity to present today. What this presentation is going to do is really consider low-carbon concretes. Okay, I will also talk about the benefits of concrete that Elaine touched on as well. How changes to specification and designs could lead to a more sustainable construction. Cemex's commitment to building a better future, as well as the current initiatives that are taking place. So, as Elaine and Tim and others will touch on, concrete is vital for the infrastructure of the UK. Okay, it provides us with clean water, sanitation, as Joe touched on in terms of the work the Environment Agency is doing. Thames Tideway will use an awful lot of concrete to bring a cleaner river to London. It's involved in low carbon energy. If you look at Hinkley Point, designed to bring us low carbon energy, will again use an awful lot of concrete. It gives us durable homes, schools, hospitals, roads, and railways. And it's probably the most important produced material in the world, not only in terms of the amount that's produced, but also the positive impact that it has on regional economic development. So I've been involved in concrete for an awful long time, so I will always sing the praises of it. As Elaine touched on, it's energy efficient. Its thermal mass benefits in terms of absorbing and retaining heat. Its resilience is resilient to fire, it's resilient to flood, chemical, physical attack. It's low maintenance. It doesn't rust, it doesn't rot. Okay? It consumes waste. So we are a waste consumer when we produce concrete in the form of recycled aggregates, crushed concrete aggregates, PFA, or GGBS. It's effective soundproofing material, okay? And we bespoke design it for any application. So whether you want early age strength, whether you want set retardation, whether you want consistence retention, it can be designed for all those applications. And it can even be delivered with its own steel reinforcement in the form of fibers as well. So it's a very, very flexible and important material to the UK. So low carbon concretes, how do we define a low carbon concrete? Because there is no value for the embodied carbon per cubic meter that would qualify concrete as being classified as low carbon. So should we be using the terms lower carbon instead? I think often when we think about a low carbon concrete, the automatic association is with clinker-free, SEM-free, geopolymer, alkali-activated materials. And these are really, really important as we move forward to a more sustainable construction. And certainly as an industry, both in terms of the concrete production industry, cement production industry, and designers and specifiers, we all need to work together to ensure that these products have their place in future construction. But it's really, really important that we remember that low carbon concretes exist today that meet current building and supply standards using cementitious products that exist today and utilizing better admixture technology. So we can produce low carbon concretes that meet today's design and supply standards. What else do we need to do? I can supply and produce a low carbon concrete. Is it important that we have a step change in how we design and specify concretes? Tim talked about reduce over specification. How many people in the supply chain add on their design margin? I know that I do, and I'm pretty sure the engineer is, and perhaps the architect is, and perhaps the contractor is, all leads to an over design of specification. What do we do about design lives? Do we design for 50, 120, or further? How does that aid, as Tim pointed out? So we're building less because we are creating products with better design lives. Compliance periods. Most of what I supply is specified at 28 days. Does it really need to be? I was talking to somebody in the piling industry at a workshop that I attended just before Christmas who was suggesting that most piles are actually loaded at 300 days. And yet the concrete is specified at 28. So if we're going to utilize geopolymer, clinker-free, SEM-free products, if we're going to utilize higher percentages of GGBS and PFA, then maybe we need to look at these compliance periods 56 or 90 days. What might be slightly contradictory is perhaps we should be looking at high-performance concretes. High-performance concretes often use higher binder contents. However, could we be designing slimmer members, slimmer applications, which actually reduce the amount of concrete that is used in total, which could lead to a reduction in the CO2 for the build? Should we be using self-healing concretes? I think Elaine touched on that earlier. There's an excellent project ongoing called RM4L, which is a collaboration of Cambridge, Bath, Cardiff and Bradford University, which is looking in detail of self-healing concretes. Can these types of concretes lead to a reduced CO2 per build? So CEMEX's commitment, we have a global commitment that was announced on the 19th of February by Fernando Gonzalez, our CEO. So we are committed to a reduction in CO2 emissions of 35% to ensure alignment with the Paris Agreement commitments. And we're committed to that by 2030. We're also committed to deliver net zero concrete globally by 2050. And we've currently got these initiatives in place to help us meet that. So all of our sites are supplied with 100% renewable electricity. We've reduced our CO2 emissions since 1990 by 38%. We build infrastructure, so hectares of priority diversity habitat created and maintained by CEMEX for every cubic meter of concrete that we supply. And finally, this is exciting times today because later on this evening we're actually launching our range of low carbon concretes. Okay, so we're formally launching a bespoke low carbon concrete which does include a geopolymer cement as well. This is the first scheme in the UK which will offer contractors the opportunity to not only buy low carbon concretes, to specify by low carbon concretes, but to also offset the remaining CO2 as well. So for the Virtua Classic and the Virtua Plus, you've got the option of offsetting the remaining CO2, and with the geopolymer cement, then you have to offset it because we all have to take our place to do it. And these are genuinely lower carbon concretes with certified offset for the remaining emissions. These and the initiatives that are currently in place, as I touched on previously, are really only the start. And I think, as Elaine touched on earlier, we have to work together to ensure that we have a lower carbon cement, concrete, and perhaps more importantly, a lower carbon construction. Thanks, Duncan.
Thank you, Richard. Okay, could all the speakers come up to the stage and grab a chair? We are going to take some questions now, but while they're getting up on the stage, I just wanted to ask a question generally. I don't know who's going to answer it, I mean. But I've noticed in the last 2 or 3 years a lot of large... Can you hear, guys, by the way? Because we did turn one of these around the other way so you could hear. Hold on. Can you hear now? Yeah, okay. I'm, as you know, based in Brighton, and we've got a lot of large developments happening, construction sites in Brighton at the moment. And I've noticed they're different in terms of the frame going up to maybe 5 or 10 years ago, because they're all in situ cast concrete. So not just a frame, but a deck and a lot of solid walls as well. And I just wondered why that's happened, because the Shard wasn't all in situ cast concrete. They used concrete where it was good, to use concrete where it did its job very well. So I just wondered, who would like to answer that question? What's the rush to in situ cast concrete?
Can you hear me? Can you hear me? Is that on?
Should be on. Are they all on? Press button.
Is that on? No? Yeah? Okay, excellent.
Okay.
I think it's I suspect it's fire.
Fire?
I suspect. We've had there's been a lot around recently. Obviously, Grenfell's had a huge impact, and I think that there's quite a lot of risk-adverse response to that.
Someone told me that all the steel was going into wind turbines, so...
Oh, well, that may be the reason. But
I don't know. I mean, it's just something I've noticed.
In the south, I mean, we construct in slightly different ways in different parts of the country.
I've noticed it's the same in London as well, yeah.
But certainly in the southeast, I mean, there's a lot of... I mean, for housing, concrete's good at acoustics as well. I mean, there's lots of benefits of why it would be used in that regard. But I think certainly I'm getting a lot of discussions at the moment from people saying, okay, look, we do a lot of housing, we do a lot of high-rise. We've got to do it in concrete because of that's the way we're being mandated to do it. So just help us do it better. Okay. And actually, that's a brilliant question, because you can do a lot, as I said.
Exactly. Yeah. Okay. Okay, have we got any questions for the panel? Yeah.
Hi, it's Mark Constantine from Ryder Leather Bucknell Consultancy. I think we're all in agreement that concrete's not going to go away. And I'd like to thank you all for the discussion that we've had, and congratulate Cemex on producing the first low-carbon concrete. I wish it had been done sooner. We've spoken a lot about ready mix here, though. I've done a bit of research with regards to concrete block manufacture, and there's companies in America such as like Solidia Technologies who are using carbon capture plus a waterless solution for producing concrete blocks. And we've also got the likes of Blue Planet in the States who are able to produce their own aggregate by using carbon capture, and you can produce that locally. So in terms of the manufacturing and the resource and the initiatives that they're doing for the concrete blocks, how do you see that flowing through into the ready mix environment?
Okay, who wants to answer that?
Yeah, I think it's working. So, I will point out that low carbon concretes have existed for an awful long time. What we have done as Cemex is to try and make the specification easier by creating a brand, a list of proprietary concrete. So I think it's only probably in the last couple of years that people are beginning to take note of the benefits of PFA or GGBS or microsilica or metakaolin to actually produce a lower carbon concrete. Okay. In terms of carbon capture, we actually, as Cemex in the USA, use carbon cure. So we capture carbon in the production of ready-mix concrete, and we certainly capture carbon in the production of cement. Our Spanish business was putting carbon dioxide into the mixing water for production of concrete, and that's a project that we've reinstigated under the banner of Cemex West Europe. So there's a lot that is going on in terms of reducing carbon in cement, which has the knock-on benefit of reducing it in concrete.
Is there anybody else that hasn't spoken yet? I was wondering if Tim wanted to answer that. You got anything to add? No, Elaine, go on, go for it.
Oh, I was just going to say, I absolutely agree with you in terms of I love those technologies, and there's examples of it on our stand over there. And there's, I don't think a lot of these things aren't quite yet out in the open until they're able to be out in the open. I'd just say watch this space. I think there's lots of really exciting things going on. I think particularly within the world of precast, as well as within in situ. And when I'm just talking concrete in whatever its form. But there's a lot of opportunity. People don't generally think of DFMA and modern methods of construction as being concrete, but actually there's lots of that. No. There's a real opportunity for that to be happening. Carbon capture in a precast enclosure.
Yes, thank you, Duncan. So what I would like to add regarding the precast elements is that cement-free concrete particularly can be an ideal solution for precast elements, and from the experience I have, works very well because actually you can easily heat cure the elements and you can get all the strength in one day or most of it. So I have used the precast concrete, geopolymer concrete is a fantastic solution. If you heat cure it, you can get all the strength in one day, so it can be ready for production after one day, so it can be a continuous production. So cement-free is ideal for precast elements, for blocks where you need high strength straight away.
Okay, any other questions from the floor? I've got one at the back, one here.
Yeah, I'd just like to say I certainly agree with Richard. Somebody who's been using 75, 80% slag mixes for the past 10 or 15 years. I've been using low carbon concrete, but I want to go into the geopolymer concrete. There seems to be a blockage in this country, and there is no standard. Unfortunately, we don't get standards until we start to use materials and we get to have knowledge of the performance of those materials. Now, like some of the people in this room, I've been on workshops here when, we can't do it without a standard. I now have the situation in New Zealand, because in Australia there is a company that is actually probably the leading company in commercial geopolymer concrete in the world. It was tested for a sewer system in New Zealand, specified by the owner, we want to use geopolymer concrete because it's high resistance, and guess who knocked it back? The insurance. It's never been used before. And until people can get out of their heads that we have to have a standard to use something. We used cement before we had a standard. Freyssinet was pre-stressing buildings before we had a standard. We have to use geopolymer concretes and low carbon concretes regardless of there being a standard.
Okay, Richard.
Hello? Yeah. Charles, I would absolutely agree. I think, as an industry, so this is the construction industry, you've seen some of the headlines coming out of Costain looking for carbon neutral build and Mace looking for carbon neutral build in the very near future. That isn't going to happen without a step change in design and specification, and insurers and clients who are going to have to all adopt a different method, potentially a different method of construction. So whether that's something taking a little bit longer or moving away from standards. I think we all know that you can actually use concrete containing a geopolymer, and you can use it even if it doesn't meet the requirements of BS 8500. So the standards aren't there to stop innovation, but I think it's a convenient reason for some people not to use it. So I think as an industry we do have to work together, and the work that Andrea's done in terms of all that test data, and bring that all together to present that to industry.
Okay, Tim,
Just talk. It'll work?
no.
No. I'm told if I keep talking, it'll work.
Yeah.
I'll just make, I think, quite an obvious point, but that we're not going to get these new standards if we don't stimulate demand. Industry will only really innovate in response to demand, so I think it falls on all of us as professionals in the specification and the design process to ask for these materials that ultimately then will trigger that sort of standards development.
Okay, let's take one more question.
The whole panel. My question was actually partially answered, but geopolymers have been around for past 40, 50 years. So why now? What's happening now? Okay, maybe the government push, I understand. But in terms of physical properties, can he actually compete with OPC? Can he, could be commercially viable for a company to invest? I'm asking Richard, for example, cement is one of the main, in the States, and us as commercial, I'm coming from New Zealand, we are a test house, so we test all sort of materials. I gotta be honest, we had 2 inquiries in the past 5 years asking to assess the geopolymers, so commercially it's not really there.
Okay,
Sure. When you say geopolymers have been around for an awful long time, absolutely they have, and we've used SEM1 as the activator, and that's still viable today. Charles has already commented, 75, 80% GGBS concrete using SEM1 as the activator produces a very low carbon concrete, okay? Where we're talking about geopolymer, alkali activated, clinker-free, SEM-free products today, that's where we're using the sodium silicates, the sodium hydroxide, as the activator, and moving away from SEM1. And equally, there's work needs to be done on the total embodied carbon for a alkali activated concrete versus a SEM1 with high proportions of GGBS concrete. So I would imagine they're not too far apart when you actually do the maths. In terms of is it viable? Absolutely it's viable, and the market will drive that. So industry will drive me as Cemex, us as concrete producers in the industry, to produce different ranges of concrete, as happened over my career from when 40 Newton concrete was most exciting and everybody turned out to watch it. Now that's a standard concrete in London.
Okay. Oh, Andrea?
Just to add, yes, regarding your question, if it can give comparable properties to OPC, my answer is yes. So you can get very good properties, so you can get even high performance concrete with geopolymer. You can reach to 60, 70, 90 megapascals. The point is you need to know the mechanism behind the activation. So it is very important also to use the right raw materials, to do the chemical analysis. Some issues, some challenges is the consistency. So you get PFA, GGPS is not the same. So you need to do the chemical analysis to see the composition, and then you need to go to the right recipe to get the activation. So the right challenges mostly linked to the consistency of the materials and the know-how. So the people need to know how it works, need to know how the activation works. The properties, you can easily get high performance concrete if you know how it works, but you need to be careful with the chemical composition of the raw materials and the activation process.
Okay, I said one more question, but I think we've got time for 2. So there's going to be one here and one over there.
Hi, I think it might be a little bit off-piste, but thinking in terms of a circular economy, I wondered if anybody knew of any use of concrete that's already there, sort of large volumes of it, in any way other than just as aggregate.
Elaine?
Well, the first thing is just use it as a building again. I mean, we're doing it all the time. There's a lot of discussion about dismantling buildings. I always make the analogy with a milk bottle. Why crush up a milk bottle to make another bit of glass bottle? Use a concrete structure as a concrete structure and reuse it and reuse it and reuse it, And that's the best way. We're building less, we're making use of a resource. And actually, if you're going forward, then what you need to recognize, if you're building a concrete building, you're building a future resource as well, because that can then be reused,
Yeah.
I've noticed that Joe hasn't said a thing.
Sorry, just very quickly.
And he said a lot.
I always say a lot. In the 1990s, we built Seven Waters' new head office just outside Gloucester, totally out of recycled railway sleepers. So it's not new, but it's got to be driven by the industry in total, as I keep saying. Yeah.
Did you actually want to say anything, Joe?
I think probably the one thing we might say is there's a lot of discussion around standards, and we're very well aware at the agency that we are one of the people who sets some of those standards in the specs that we put around the material that we ask for to build flood risk management assets. And so we're all the fact that we need to engage with the industry and engage with our supply chain to understand how we can better change the specs that we currently use to encourage that movement towards a low carbon process. And it's something we're actively doing at the moment.
Okay, really good question. We'll have one more.
Right, just talking about the low carbon or geopolymer concrete and cement. Issue is we talking about quite a lot about low carbon, but actually we talking very little about the material property, strength, stiffness, something like that. And some people think it's a new kind of material, some maybe totally just the OPC replaced with the traditional OPC with the, some kind of gel binders. So my question is, on the one side, using geopolymer, we can reduce the low carbon, no problem. How the property will be changed? It is a new property, or it is we can still inherit the traditional specification or code or standard. This is one issue. Another issue is, when Gus was just talking about using added fiber to increase the tensile property. My understanding, if you added some fiber into this kind of material, could have potential hazard because the fiber is diameter quite smaller, because the industry maybe have hesitated to using these. So that's my opinion, because I know in China normally we're not allowed to add the fiber into the cement, the concrete, because it could have potential, the hazard for the worker and like asbestos in the future, or that will have potential issue. So we just discussed about this problem, what they have added some kind of gas fiber or carbon fiber into the cement. So.
Thank you. Yes, again, thank you for the question. So regarding the properties every time is different. So even if you have normal concrete and you change the aggregates, the sand, you have high performance, every time the properties is different. If you are talking about the stress strain models, and if we have to create new models for geopolymer concrete, the concept is the same that with the one we follow for conventional OPC. Overall, the behavior is pretty much the same. Clearly regarding, depending on the mix, you get different strengths. The behavior is pretty much the same. So good compressive strength, weak tensile strength, brittle in tension. So it's pretty much the same also the Young's modulus, if you want, with the conventional concrete. So we should treat this as normal OPC. Now, the properties we can get, as I mentioned previously, can be very good. We can add fibers as we do in the normal concrete to increase the tensile properties. If there are issues with the steel fibers for durability and so on, we have found that the polypropylene or glass fibers work very well too. The important aspects we need to check is the bond between the fibers and the geopolymer concrete, which is affected by the actual composition of the raw materials. So we have done research on this, and we have optimized the mix in order to offer the best bond between the fibers and the matrix, the geopolymer matrix. So just to conclude, you can have very good tensile properties and very good ductility. We have used it for the strengthening of structures. We have done direct tensile tests to find the energy absorption, the direct tensile strength, and you can have some very good properties with a wide range of fibers, not only with steel, we have used polypropylene and glass fibers too, and it works quite well.
Okay, we're going to have to wrap up there. I mean, I think you get from the floor here that, you know, we have got a great panel today. There's a lot of expertise there and across the board from sort of end user, designer, researcher, and I just was rather impressed that you guys sort of had a plan in a way. I mean, I think at the beginning with Tim, with that very steep descent slide, we can just see the challenges that we have got. And we've got it as an industry, and we've got it as a community of people that live on planet Earth. So concrete isn't going to go away, but we have got to find low carbon solutions to it. And thinking of it as a valuable material in the first place is a good start, something we want to treasure and look after rather than throw away. So a final hand for all the speakers, please.